We began by measuring the coefficient of friction between the marble and the plywood track. To do this, we lifted one end of a 1-foot section of track until the marble just began to roll. The lift height was measured as 1.9 inches, which corresponds to an angle of approximately 9 degrees. Using the relationship mu equals the tangent of the angle, we calculated a friction coefficient of 0.16. Next, we calculated the ideal minimum height required for a 2-foot loop with no energy losses. Using energy conservation and the minimum speed needed to maintain contact at the top of the loop, shown by the equation velocity squared equals gravity times the radius of the curve, we determined that the marble must start from a height of approximately 2.7 feet. This represents the theoretical minimum height in a perfect, frictionless system. Because real systems experience rolling resistance and frictional losses, we selected a higher start height of 5.5 feet for our initial design. We modeled the coaster in SolidWorks and measured the track length from the start to the top of the loop as 11.36 feet. Using our measured friction coefficient and the equation H minimum equals 2.7 plus mu times L, we calculated a required height of 4.52 feet. Since our actual height of 5.5 feet is greater than this minimum, the marble has enough energy to successfully complete the loop. We then analyzed the 1-foot hill that follows the loop. To determine the marble's speed at the top of the hill, we used energy conservation, while accounting for friction over the 16.7 feet of track. From this calculation, we found the velocity at the top of the hill to be approximately 9.15 feet per second.